Hi everybody, welcome to this session. In this session, we will focus on the Google Collaboratory, the Jupyter Notebook based Google solution for carrying out all the Python machine learning and all other works. Okay, so first of all, when coming to the coming from the Jupyter Notebook background, you might be familiar with the interface. This is the welcome screen of the colab.research.google.com, and when you come across this website, you have the file menu, and there is also the other menus that you can use. In file menu, you click new notebook for opening up a new notebook, and okay, as it is taking a bit more time, let us go back to our previous tab. Okay. So in this, as you can see, there is a code cell and there is a text cell. In code cell, you can type in the Python code. As you are familiar with the Jupyter Notebook, this is similar to the Jupyter Notebook, and it is having a block of code that you can use it for typing your Python commands, and there is another block of code that you can use for inputting or giving your text commands. Okay, so for text commands, this can be taken. Okay, as you can see in this cell, the second scenario is compiled, and now this tab is open. Okay, so one second, yeah, so the second sensor day is here, and we can just run it, and 86,400 is the number of seconds in a day. So this is how you can run a Python code, and when you are hovering over the tab, you can add it another text tab or code tab. Okay, so when I double click on a text tab, you can see that it is only a HTML tag. It is having a div tag h1, a simple paragraph. It is having a center tag, that is it is having a link that is centered, and this link is actually a YouTube video that is embedded in using the embed code from the YouTube. And similar to this, you can also embed your HTML content. You can directly add your HTML video, or you can add any other content in the this Google Colab notebook. Okay, so now typing a simple hello world program, str equal to hello world. So this hello world is actually I'm renaming the variable to string. So I have just type the content, and I am just pressing the run button, that is the at the right left hand side, and when running this command, it is actually executed using the control plus F5. So sorry, the control plus enter. So when we press the control plus enter, this cell will be executed, and the variable, the string, will be allocated in the memory or containing the text hello world. So next I press on the code or text cell. Now I press the code cell, and as you can see, as soon as I press the code cell, I can directly type in the variable here. And because it is Python is an interpreted language, so when I type the variable, you can see the result hello world at the bottom. So this is how you can run a Python code in a Jupyter Notebook within the Google Collaboratory. So so this solution of Google is very intelligent, and you can directly add in another cell just by clicking the alt plus enter, which compiles the previous code and also adds the new cell below the above one. So similarly, you can add an text cell also, through which you can include any HTML content in your Google Colab notebook. And let me once again just demonstrate that to you. And coming to the text cell, so when I click it, and you can see that I'm just typing a new paragraph. So whatever that we give inside this block of code is displayed as a HTML element. Okay, so this is how a Jupyter Notebook will handle any HTML content, and that is the same way this Google Colab is also handling the markup text. Okay, so as you can see, this is a paragraph, simple paragraph that is here, and when I double click it again, I can edit it, and I can even add a h1 tag or any bullet or any paragraph tags, or let me just add in a h1 tag. Let me just give it as a paragraph tag, and I'll just add another h1 tag at the top. Okay, so I give the h1, and welcome to Google Colab. I'm just giving it here, and I'm enclosing it within the closed h1 also. So when it click outside the particular cell, you can see the results also. Okay, so this is the way you can create a HTML content in the Google Colab. So this can be used as a hint for your the code you write, and this can even be break down into sections. So using hash, we can define a new section or a new subsection. This is similar to the heading h1, h2 up to h6 HTML tags. So this is the way we can segment the code into multiple sections, many subsections, and this section wise categorization will help in reorganizing, or we will be able to easily understand our code, whatever we are writing in the Google Colab. So as you can see, I'm just giving a double hash, so that means this is a subheading that is given under the introduction. So this will be of level 2. This is heading 2 formatting will be applied, and you can note the subsection in the table of contents as well. Okay, so this is how we can create a Google Colab notebook, and you can just go at the top, and you can type in your names, and you can just rename the file, or you can just press the Control S to save the document, and it will be automatically saved as well. So you can basically you can just go to the file menu. You can upload a new notebook, or you can directly save a copy in your Google Drive, or you can save a copy in your GitHub. You can directly save it, or you can download it as well. You can download it as a Jupyter notebook with the extension IPYNB, and also you can download it as a Python file also, individual Python file, which you can run locally in your native machine. Okay, so this is how you can work with Python in Google Colab. Coming to the main portion of our work, that is a machine learning. So this the Google Colab, that notebook that I have, is here for the classification using decision tree. Okay, so this decision tree is basically used for the classification problem, data mining problem, and it is part of the supervised machine learning algorithm. So we are just using the classification problem, and for decision tree I'm using the Guinea indexing. So this Guinea indexing is the metric for that is used for splitting the nodes at the decision tree. So as you can see, the left hand side I am splitting it in a table of contents, and the step 1, step 2, step 3, all these are categorized for easy readability, and we can improve the readability of our code also. Okay, because we are using Python, we can split up into many particular modules, and these modules can be individually run as well. Okay, so we are basically using the Scikit-learn machine learning library for the decision tree, and also there is something called as model selection, which we will be using for training and testing, which can be used for training, testing, splitting, and we can evaluate the classification algorithm. We can use a confusion matrix, or we can use a accuracy also. Okay, so such a type of modules is already present in as part of the Python's library. We are just importing using the Scikit-learn library, and also we are using Pandas. Pandas is a library for reading and writing CSV files. We are creating a data frame using it also. So these are all the import packages, that is all the things that are needed, and the next we give it as a import data. So this is basically a function that sorry, so this function is actually used to just download the data from a particular website. Okay, so we are using this to download the data from the UCA repository, and this UC repository will contain many classification datasets. Okay, as you can see, so this I'm just opening the URL. Okay, so this is a UC repository that is here, and you can open from a wide variety of classification, clustering, segmentation on all these datasets are there, which you can apply for any problems, research problems also. So I'm just opening the data, that is a balance data that displays the scale information in a shop. Okay, so the balance data, and for this data we are using the URL, and we are reading that CSV file from the Pandas library. So we have the balance data, which is a variable that we use to store the pd.read CSV. Okay, so when coming to the resource, okay, so this will have this set of data sets, that is a balance, scale, weight and distance weight database. And we can as you can see, this is a source information, and there are a lot of information given here about the dataset and who has is the donor of the dataset, and all this class information is also there. So regarding the number of instances, there is actually 625 instances are there, that is 625 records are there, out of which 49 are of balanced classes, and 288 are of left classes, and 288 are of right classes. So the target class is basically consisting of three values that can be given as input for the target class. So basically the predicted output will either be a left or a right or a balanced. So in such a way, the balanced totally 49 balanced datasets are there, and 288 left datasets are there, and 288 right datasets are there. And the number of attributes are 4, and that is numeric and particularly a class name. The target class, that is a 5. Fifth one. So coming to the attribute information, the class name is having three values. It can have three values, that is a left, L and B balanced, and R right. So other than that, there are four values, that is from the left weight and left distance, and right weight and right distance. So these kind of values are all the parameters, that is attributes, features of the machine learning algorithm, and these features are used as a training medium for training the machine learning model that we are going to solve in this problem. Okay, so this is how the attribute information can be read from the UC machine learning repository. And when we have some kind of a research problem, we can directly access the UC repositories, and we can even see the class distributions here as well. Okay, so this is the way we can directly load the data from the UC machine learning repository. And when we open up the CSV file, there is a comma separated value. So as you can see, all the values as B, L and R are the first column, and 5, 5, 3, 2, 1 and 1, 1, 1, 1, and all these values are there at the as part of the features. Okay, so coming to the Panda module, so we are using the Panda, that is a pd.read CSV. So this pd.read CSV is actually a method. It is actually a function that is used to go read a particular CSV from a URL. So we are having the URL at the data 1, and that is the first parameter, and the next parameter is the separator, that is a separator. This separator is actually used for separating the data in the file. So actually it is a CSV file, so hence comma will be used for all the column differentiating all the particular attributes. Okay, all the features. So separator is given as comma, and header is equal to none, because we don't have a particular header row at the top of the dataset. And we just this function actually converts the data loads the data from the URL and converts it into a data frame, and it returns the dataset. Okay, so this dataset is in the form of data frame, and when we call this particular function in import data, this function actually returns a data frame, and Google Colab intelligently displays the data frame in a formatted way. As you can see, this is similar to one that we saw in the notepad just now. Okay, so this is how we can call a particular function, and we can directly load data. So this is the first part is basically we are loading from a UC repository data, this dataset is being loaded, and we can load this data and convert it into a data frame, and this data frame is later on we will later on be using this data frame for our machine learning problem. Okay, so coming to the next step, we are going to split the data. So in this split the data, we are having the balanced data, that is the data is that we are having from 1 to 5. Totally there are 5 instances and 5 columns, sorry. And in the first column, as you can see, there is B and R and R and L, this kind of values. So these are all the target values. So this is given in the Y. Okay, this is the target variable that is in the data set, and all the other values, the 1 1 1 1 1 1 1 1 1 2 and 1 1 1 3, and these kind of values, these kind of other numerical values, and all these values are of the X. So such a way we are splitting the features and the target class, and then we have the X train and Y train, X test and Y test. These are all the values that the train test split function will be returning. Okay, so we are going to split the dataset into training and testing. Okay, so this training and testing splitting can be used with the help of train and test split. As you can see, train test split is part of the model selection module in the Scikit-learn library, and when we import that library, we can directly use the method, and we can the parameters are basically X and Y, X comma Y. Okay, X is a set of features, Y is a set of target variables, and then we have the test size. This is actually the test size is equal to 0.3. So that means that there are 30% of records are used for testing size, and the remaining 70% is used for training the values. Okay, so when coming to this figure, you can see that the testing set is it is actually 30%, and the remaining training set is used as the 70%. And this training set is used for training the machine learning algorithm, and this when the machine learning algorithm is being trained, it is actually tested with the data the records from the testing set, and this is done for validating the classification model. And similarly, the validation set may also be taken from the training set for validating the model further. Okay, so this is how we split the dataset into separate training and testing sets for validation. So as this decision tree is going to be evaluated, so we are basically in need of splitting the dataset into this kind of percentages. Okay, so this is a simple basic definition for splitting the dataset, and you can give basically the random state as anything else, any number from 100 or even 1000. So it will basically return the X, Y and X train and X test and Y train and Y test. All these values will be returned when we call this function. So we just call the split dataset, and this dataset is we need to give the dataset. So if I give the data 1, so I think it is a private variable. So if I give it as data 1, so it will not be accessible. Yeah, so it is actually a private variable. So hence I'm just going to call the import data. This function will call the data, and it will return the data frame. So I basically just call the import data, and this import data is being called in the split data set. So this way we can split import the data, and we can split it into the training set as 70% and testing set as 30%. Okay, so likewise we can view all the records and all the values that we have here. Okay, so this is how we can load the data, and you can see that it is displaying all the number of values that is present here, from balanced right and left, and all these kind of values are there. Okay. Sorry, such a way we can load any kind of data sets, and any kind of data sets can be loaded, and the training and testing split can be made for training the classification algorithms. Okay, so the next step is to use the training and testing split for training the classification algorithm. So we are using the decision tree classifier, and this decision tree classifier is having the criterion as Guinea. So Gini is a Gini coefficient which is used for splitting up the tree. So Gini impurity we are using, and then we are based on the Gini impurity level, the decision tree is constructed, and the random state is equal to 100. The maximum depth level equal to 3. So three number of 3 depth of tree is there, and minimum samples is 5. So the CLF Guinea is actually a decision tree classifier that is created using the decision tree classifier function. This is actually a function, so it is actually calling a constructor of the decision tree classifier class. So next we are going to just fit the model into the data. Okay, so we have the xtrain and ytrain. We are fitting the decision tree model to the xtrain, the training features and the training class labels. So all these are training label features, and for all these features, all these training labels are there. We are making the decision tree learn using the fit method, and we basically just return the CLF Guinea, that is a classifier object that is created. So using this we can just call the train using Guinea, and we can directly create a decision tree classifier, and we can fit the model and we can return it. Okay, so next, coming to the prediction. For prediction, this xtest and C classifier object is passed here. This xtest is the number of that is a the testing features that is splitted at the top. So we are giving a set of test features, and using the classifier, that is the second parameter, this predict function is called, and this predict will predict the possibilities, that what are the predictions that the x text will have, that is returned in ypred, and this ypred is returned to the calling side using the ypred object. So this function actually makes a prediction based on the testing features that is given to the function, and the classification object is the CLF object that is passed at the second parameter. So the ypred is returns the predictor, and the next one is the call accuracy. So this is actually getting the number of testing labels, that is test features, okay, test labels, and the predicted labels. So what are all the actual labels and what are all the predicted labels? So that is given as the first parameter and the second parameter respectively, and based on this the confusion matrix is created. Confusion matrix is basically a module that is part of the scikit-learn machine learning library. So as you can see, it is part of the scikit-learn metrics module. So we can use the confusion matrix for knowing all the precision, recall, F measure, and accuracy, sensitivity, specificity, and these kind of things. So next one is the accuracy. So this is called using the accuracy score for as this accuracy score returns an integer value, numerical the floating point where ranges from 0 to 1. So we are in need for multiplying it with 100 in order to display it as a percentage. So next we basically call all these functions in order. So data is equal to import data. We import the data, and the next when the data is imported, this data is passed to split data set, and the xtrain, ytrain, xtest and ytest, and x and y, all these values will be returned, and based on these values the train using Guinea is called. This function will use the Guinea impurity for constructing the decision tree, and when the decision tree is created, this decision tree object is passed to, it is actually fitted, trained with the dataset, and it is returned to the CLF Genie. And when the CLF Genie is trained, it is actually a trained model. So we call the prediction function with the x test, that is a number of testing features that we have, and the second object is the CLF Guinea, which is the classifier, and the predicted labels, all these predicted labels will be returned to as ypred Guinea, and the call accuracy, that is used for getting the accuracy and confusion matrix. So y test is the number of testing instances, and ypred Guinea is the predicted values. So actual value is y test and predicted value is ypred Guinea. So I go to runtime and run on, and now as you can see the shortcut is Control F9. So when I click run on, all the cells will be executed, and as you can see the predicted values is displayed, and confusion matrix is displayed, and 73.40425. so this is the accuracy of the decision tree that is created with the 30% testing set and the 70% training set. Okay, so this is basically how we can run a particular decision tree classifier using a scikit-learn library, and these are all the just packages that is required. So in this manner you can directly try your best, or change your settings for changing the training set and the testing set. You can even play it with your number of percentages that you have, that is 0.2, 0.3. Based on the values you can just change the data training needs, and these kind of data training needs can be given as in terms of 10%, 10% for training, and for testing and validation, and the remaining 80 can be used for training. And you can basically just train the machine learning algorithm. You can any machine learning algorithm can be trained similar to decision tree, and likewise based on the features of that is given to the function, or this predictions can be made. Okay, so let me just change the split dataset to have the split criteria or the split range. Okay, so this split range is actually a test size that it is, we are just going to let me just keep it as a test size. Okay, test size, so no confusion will be there. We just will, let me just copy it, test size, and I'm just giving it as a test size. And after that we give the if I run it, it will show error as there is no second argument is there. So the second one parameter is necessary, so I give comma and 0.2, and now as you can see it is 20% is used for testing and 80% is used for training. So similarly this value can be changed in the calling function sections also. In the split dataset, now I give the 0.2, 1 second. Okay, I give 0.2, and now I click run all. As you can see, the all the modules is running, and you can see that the classification accuracy is 70.39%. So such a way the accuracy is differing when given for 0.1 also. So now 0.5 when change for 0.1, it is 74.60. so as 90% is used for training and only 10% is used for testing. So more number of training means the classifier will work better. So this is a general concept in machine learning. So when the machine learning algorithm is trained more, it will predict very good. So such a way you can vary your data training needs, and you can directly play it with your values that you have tested data, and based on the training and testing set, you can directly change or apply any values. You can directly load in any data set, and in a similar fashion you can apply this model, or you can directly work with this code for any machine learning problem that you have. So this is the way that you can work and evaluate, or you can predict any values. So coming to the prediction, you give y predict guinea equal to prediction of x test and CLF guinea, and when we get the y predict guinea, this is actually the predicted value for the x test training features that is used for testing purposes. Okay, so when actual values is printed, the 1 second, it is actually the okay, so x test is actually the test feature. So if I print the x test, all the testing features, that is the 1 second, all the testing features having the values from all the integer values, that will be printed, and in predicted values, all the predicted values will be displayed. Okay, let me just give it in a print. Okay, so these are all the training features, all the testing features, and these are all the predicted outcome. Actually x test is given as prediction, so it should be actually y test. Okay, no, y test is actually not capital Y, so that is the testing features only. So for x test that is given here, and actual test we can change it as a y test. So that way the actual values will be shown, and the predicted values, after the predicted values will be displayed. So as you can see, these are all the actual values that is of the dataset. So when we check the dataset, these actual values are L and R B R L R. So these kind of values are there. So in the predicted values, you can see that the sixth, 1 second, 1 2 3 4 5 6, as you can see, in the sixth instance, sixth record, for the sixth record, it is actually values B. For the sixth record, the actual value is B, but our classification algorithm, that is a decision tree, predicted is as L. So it is actually a balanced one, but our predicted outcome, that is decision tree, predicted it as a left class. So this kind of misclassifications can happen. So such kind of misclassifications can lead to error. So these kind of errors you can just refine it. You refine your classification algorithm, or you can directly refine your any methods that you have, or using any advanced strategies, you can directly update your machine learning algorithm also. Okay, so thank you very much, and I hope you have understood decision tree classification in this video. Thank you very much for joining. Please subscribe and like the videos. Okay, thank you.